Everybody. I'm just going to take a moment to stop these videos for AI note takers, but you guys can feel free to share your video if you would like during this workshop. Just going to give it just a minute here. Okay. All right, thank you guys for coming to the last workshop of the day. It's a workshop about NEAR with Owen. So thank you, Owen, so much for being here, and I'll let you take it from here.
Awesome. Thanks for that. Yeah, so we're going to be getting into building DeFi on NEAR, specifically to do with this hackathon and 1-inch Fusion Plus. Oh, can't get my words out already. So I'm Owen. I'm the DevX lead at Proximity, which is basically a research and development organization within the NEAR ecosystem. And we're mainly working on like decentralized agents at the moment and cross-chain signatures, but we have a very strong background in DeFi. So I guess that's why I'm here. So to get into it, there's two bounties that are NEAR related. The first is as part of 1inch's bounty, and that's expanding their Fusion Plus cross-chain swapping to NEAR. So that will contain like implementing some contracts on NEAR. And then the other one offered by us is building a Fusion Plus decentralized solver with our decentralized agent stack called the Shade Agent Framework. So this presentation has sort of two sections here. The first, we're going to focus a lot on the key concepts and smart contracts on NEAR to do with this first bounty, and then we'll go on to getting into like the decentralized solver. Oh, and if you have any questions, I'm just a one-man show here, so I'm happy to take them all at the end. I don't know if you can join live or I can just respond to ones in the chat. So the requirements for this first bounty set out by 1inch is that you need to preserve hash lock and time lock functionality for the non-EVM implementation, so the implementation on NEAR. You should be able to do swaps both ways, so from NEAR to Ethereum and from Ethereum to NEAR. And the token transfer should be live in the demo, either on mainnet or testnet. And then ideally you implement a UI, partial fills, and relayers and a resolver in there. But yeah, these are not hard requirements, as you can see. So sort of translating these requirements into concepts, this is what I've come up with to do with like the main things you need to learn on NEAR. So the first would be, how do you even create a NEAR smart contract? Then looking into timestamp in contracts related to this time lock functionality, then handling fungible tokens. Obviously, this is involving swapping, so that's going to involve fungible tokens. And finally, interacting with the smart contract you've deployed, either for like testing, for a demo, or if you're implementing a UI. So smart contract development. On NEAR, our contracts are predominantly developed in Rust. You can do them in TypeScript, Python, and Go, but I would recommend that you do it in Rust for this hackathon. And with Rust, how you're normally building and testing projects and managing dependencies is with Cargo. We have an extension to Cargo called Cargo NEAR, which allows you to just get up and easily started with NEAR contracts and testing them. So if you literally just type in, you install this, type into your terminal Cargo NEAR, then it will present you with a list of commands that you can take and you can click through the options. It's quite nice and interactive. But some of the main ones you'll be using is Cargo NEAR New, which sets up a new project. To actually test the contract, you just use Cargo Test. If you need an account to develop with and deploy the contract with, then you can use cargo near create dev account, which will create you a testnet account and pre-fund it with some testnet tokens. And then finally, cargo near deploy, which will obviously deploy your contract to an account on testnet or mainnet. And you should be using the most recent version of cargo near, and you should pin your Rust version to 1.8.6 or a prior version, because the more recent versions are not yet supported by the near blockchain. So if you're having some strange errors, some like deserialization errors, which I've seen a few of you have had already, then this is the cause. You should pin your version to 1.86 and make sure you're using the most recent version of cargo near. So what does a near contract actually look like? They're really quite simple, as you can see. This is just a simple like hello world example, or hello near. Up here, we're importing some things. We're importing near, which is the main thing, and some logging functionality. And the first thing we do is define the contract structure and the contract state. And we have this near contract state macro here to do that. And this implements some like serializers under the hood, basically. So you can store it to the chain and print it in JSON. So this contract is just storing a greeting, and that greeting is a string. And your contract needs to have some initial storage to it. So you implement an initialization function, and this one, like you can implement an initialization function here to set it to what you want. Or you can implement like a default implementation, which is defined here. So whenever you launch the contract, then it's just going to initialize it with hello as the greeting. And then into like the actual logic of the contract, what we do is we implement the contract and add the near macro on top, which does some things like creates you an ABI and makes it exposed to the world, basically. So we have two methods here, and there's two different types of methods, as you'll know from like EVM. There's like a view method that just views the state of the contract and doesn't change anything, and that requires no gas. So here we have this get greeting function, which is literally just going to print the greeting out that's stored in the contract. And then here we have a call method, also known as like a change method, which you can call the contract to set a new greeting, and that's just going to log it and then change the stored value. So pretty simple. And then if you're writing a contract, I know this is a hackathon, so people don't tend to like to write tests, but I think tests are actually the best way to check your contract is working as it's expected. And it's easier to iterate on this than just like manually testing via the CLI. So we have two types of tests here. The first are unit tests. These are very modular. As you can see, there's one test for each function here, and they're very simple. You can see this one is just getting the greeting, and it should be set to this default hello. And then the other one is setting like a new greeting and then getting it. These are very modular and like great to make sure each individual function is working. And then over here we have integration or workspace or sandbox tests, as they're called. And these test like the whole flow of the contract and let you have outside state that is not just your contract. So you can actually implement and start up fungible token contracts that will actually integrate with your own contract. So as you're building your contract, I really recommend, like, you don't necessarily need to do unit tests, to be honest, but I really recommend you do some workspace tests, integration tests, and test with some like fungible tokens and make sure the flow is properly working in your contract. Then uh, timestamp. How do you handle time in a contract? So if you import env as part of like near SDK, if you just put env in here, then you get access to block timestamp and block timestamp milliseconds. So the first one shows you the timestamp of the block in nanoseconds, and then obviously MS is in milliseconds. So if you're implementing this feature where like a solver's quote expires after so long, you can set it a timestamp, and if the current timestamp in the block is past the timestamp of the quote, then you should deny someone taking up that quote, right? And this timestamp is given in the usual format where it's the number of nanoseconds since the 1st of July, 1970. And you can actually use this timestamp inside your tests. So for unit tests, you can use block timestamp in the context builder. So you can build context up to say the current timestamp is like today's date or a year from now or whatever to test your individual functions. And then you can also test this in integration tests. This works a little differently because integration tests actually like spins you up a local node under the hood, and you can't just set the time to whatever you want because that would go past the rules of the blockchain. So you actually fast forward a number of blocks. So I can fast forward like 100 blocks in this example. So to get into using fungible tokens on like with near. So if you're interacting with a fungible token and I PyVortex.near, that's my account name, want to send tokens to Alice.near, as you can see in this example, I have to register them in the fungible token contract to basically pay for storage. And we can do this by calling the token contract with the method storage deposit and specifying their account ID. And we do have to deposit some near. I believe this is it's either 0.125 near or it's 0.0125 near. I think it's the second one. And this just stops like spamming the contract. So yeah, you're paying for the storage. Then to as part of this, you're going to want to like lock tokens in a contract to actually transfer them. So to do this, you need to implement this method FT on transfer in your contract, and it has to be called FT on transfer, and it has to implement these args, sender ID, amount, and message. So the sender ID will automatically be filled in, and it's like who is actually sending this token, and the amount is obviously how much is being sent, and then the message is some arbitrary string of who of whatever you want it to be. So this could be like what type of transfer it is, like what action you're taking. And so we have this over environment function called predecessor account ID, and this gets the account ID that called this contract. And this is actually not the same as the sender, because the sender calls the contract, the token contract, and then the token contract then calls your contract. So the predecessor is actually going to be the token contract. So this will be like USDC.near or USDT.near, for example. And you should, if you're only accepting like a certain number of token types, then you should be checking like, is this fungible token contract the one I'm expecting? Then once that's passed, you should have some other logic in there to say, hey, Owen has deposited this amount of USDC. And what you should do is you should return an integer to basically, not an integer, but like a number stating how many tokens you want to return to the token contract, well, to the user. Because if something goes wrong here, or you don't want to eat up all of the tokens that were done in the transfer, then you can send it back to the user. But because this is like a successful call, we just return 0 here because we're using all the tokens. So that's how to accept deposits in your contract. But to actually like make a deposit, what you need to do is call specifically FT transfer call on the token contract. So you're calling contract ID here, but then you're actually specifying the receiver ID. So the contract ID here is going to be like USDC.near, and the receiver ID is going to be this contract. So this is going to be like Fusion plus .near, for example, and then specify the amount and the message, and the message just gets passed through here. And you need to attach some gas and attach a deposit of 1 Yocto near. And that's just to check that you are actually like the owner of the account. So it requires deposit. So you actually have to sign the transaction. And if you want to transfer some fungible tokens from a contract, so when you're receiving tokens onto near from like Ethereum, you need to make an FT transfer call from your contract to the user. So this is done with this function called FT transfer, where you just specify the account ID and the amount you're sending. And we usually implement this as like a trait in Rust. So you define this like FT contract as an external contract, and you implement this function interface, and then you can use it here. So I'm calling the FT contract, and this is the account ID of the FT contract. I'm attaching a deposit, which we know is 1. I'm attaching some gas, and then I'm using the method FT transfer. And this is the account ID I'm sending it to and the amount I'm sending. And if you need some like testnet fungible tokens, or you want to set up your own fungible tokens, just let me know on Discord or Telegram, and I can help you navigate that. So to get into like interacting with your contract once you've deployed it and you're happy with it, there's 3 main ways to do this on Near. The first is the wallet selector, which is using a wallet from a front end. The second is Near API.js, which will usually be used from like a server, or it could also be used from a front end as well. And then there's the Near CLI, which is obviously just a CLI in your terminal to interact with it. But this is not going to be like a UI or a server. This is just like manual calls you're making. So first, with the wallet selector, lets you use your Near wallet. Pretty simple. You can see a sample front end that uses the wallet selector by typing in npx create Near app latest. So you'll see in this example how you should set up the wallet selector is you define this like configuration where you set the network ID, which will be like mainnet or testnet. You can leave out this access key. This just means that you don't have to sign every single transaction with your wallet, but you could ignore this. Then there's modules, which are which wallets you're supporting. So here I'm supporting Meteor wallet and Here wallet. And then you need to like wrap your application with this wallet selector provider context. Yeah, you pass in the config here to this, and this will let you use the wallet selector within your app. And to actually like use it, you need to import wallet selector, and then you can get these functions from wallet selector, which are view function. This is like a hook that just allows you to call a contract to see what the state is, as we talked about view functions before, and then call function, which is actually changing something or like doing an action inside a contract. And then we also have available to us signed account ID. So this just tells us what account ID is logged into the wallet currently. Then to come on to near API JS, like we say, this is used mainly in like a server setting. So it's pretty simple to use. This is an example of just making a function call to a contract. So we import a few different packages. They're split up into different packages here. We have like an account, a provider, and assigner package. Here we're just pulling out environment variables from our like .env file. So first what we do is define a provider. So this is the RPC that we'll be interacting with. Here we're using Fastnear, which is like a free RPC. We're grabbing our private key from the environment variables and then creating a signer from that, which will sign transactions. Then we create this new account object where we're passing the account ID of the account I'm using, the provider so I can send transactions, and the signer so I can sign transactions. And then we're making this function call to this guestbook contract to add a new message. Pretty simple. And there's a load of different functions available here, like viewing balances, view functions, and querying other things on the blockchain, or like sending transfers. And then the CLI, I mean, this is really simple. Just install near CLI. If you search that up, I've dropped some docs in the Discord. Just type near and you're ready to go. If you type near, then it'll pop up with like an interactive CLI where you can select what you want to do. So an account will let you like create an account, delete account, manage its keys. Tokens will let you transfer and view your balances of fungible tokens or near. Contract you'll probably be using the most. This allows you to make view calls to contracts and call functions on contracts and deploy them. But you should, for like contract deployment, I'd recommend you use Cargo Near. It's a bit easier to work with. So that was everything to do with the first bounty, integrating Fusion Plus onto Near. This is obviously just like a brief overview, so do let me know if you have more questions at the end or async in Discord. So to get on to the decentralized solver bounty that we're sharing, like I guess a lot of you won't know what a decentralized solver is. I didn't really understand it until like a month ago. But basically, Fusion Plus and other networks operate on like a system of solvers to fill orders. So instead of a system where you have like an automated market maker pool where you have like two pools of assets and you're swapping between them, this system works by you have individuals and companies that act as solvers to solve requests. So they'll like take USDC and fill it with Near or Ethereum or whatever. So a decentralized solver is basically just a solver, but it's not controlled by an individual, and it works according to like verifiable code that's running in a trusted execution environment, which we'll get into a bit later. So this, like why use a decentralized solver? It doesn't really matter for the solver, but it matters for the people who are interacting with it. So it stops a solver from rugging a load of people's funds. So if you want to provide liquidity to a solver, then with a centralized solver, they could just take your funds essentially. So this system allows you to, as like a user, to provide liquidity to a solver and get some rewards from that. And solvers, this means like solvers don't have to have a load of upfront tokens. They don't have to have loads of liquidity. Anyone can really become a solver. Like anyone can contribute to a pool. and people will just like delegate their tokens to the solver so they can solve more requests and be profitable. So we actually have a similar system to Fusion Plus on Near, which is called Near Intense, and it behaves very similarly with like a network of solvers. So we have an example that's posted in the Discord and on the bounty description, which is a solver that's solving for the Near Intense network, and it's decentralized using Near Shade Agent framework. So yeah, this solver runs in a trusted execution environment on Fowler Cloud. Fowler Cloud is a provider that enables people to deploy applications to trusted execution environments. And a TEE, trusted execution environment, I'm saying trusted execution environment, trusted, blah, blah, blah. It's a bit of a tongue twister. So these are basically like hardware secured environments that are tamper proof, and they have verifiable execution. So you know exactly what code is being executed, and you can literally get an attestation to show that it's running how it should be. So we have these like solver agents that are running in a TEE, and they're using you can verify they're using the correct code, and that is done by like registering the agent in a near contract. And once it registers in the near contract, then it becomes a valid solver. And this contract actually has liquidity pools and like pairs, so users can provide their own liquidity to the solver, and the solver make swaps within that pool to solve requests, which is really quite cool. So these example repos, there's like first a solver deployer manager that spins up new solvers for people for like different pools and manages them. Then there's the pool contracts and the solvers themselves. So your task is actually to modify these repos, or to create like, or start from fresh to adapt the solver to work for Fusion Plus instead of Near Intense, basically. And to get into the requirements for this bounty, basically your solver must listen for quote requests like any solver. It must produce, be able to like solve these orders, and it needs to use Near's chain signatures, which we'll get into in the next slide. It needs to have documentations with how you can set it up and demonstrate it actually working. And then bonus points if your like code is good and it's modular. So this could be extended to even further solver protocols. So I mentioned chain signatures like twice this time. Chain signatures is a method for signing transactions, or signing like random messages, arbitrary messages on Near with like a decentralized MPC network where a load of different nodes jointly sign a message and no one is really holding one key. I can't really get into it too much here, but you can research in the docs about this. So we use chain signatures and MPC signing to sign these transactions interacting with Fusion Plus, because this means if the TEE goes down, then the keys won't be lost. Because if you are running a solver just in an individual TEE, if that goes down, then the keys would just be lost forever, and the funds associated with that would be lost forever. So we use the Near contract that the solver agents register in to manage the keys. And if you look in our docs, then the Shade Agent Quick Start has an example of using these chain signatures from the agent contract. And in our example, there is like there's pools, as I say. You don't have to use this pool structure. You can use whatever structure you want. The pool one is probably quite a nice one to base it off since it's already there. But realistically, users should be able to provide liquidity to your solver in some way, and you can change this to be how you like. Yeah, resources we've discussed a lot here, and I refer to a lot of links. So I don't really expect you to find them for yourselves. But if you go to the ETH Global Discord and under the near section, all these lists, all these links are posted there. There's about like 50 links, not that many, like 20 links I went and found earlier. So that will reference everything I referenced here. And just some QR codes I'll leave up for a bit whilst if we have any time for questions. Here's a link to the Near docs. It's just docs.near.org. And here's my Telegram if you want to reach out for any questions. Like you can use the Discord, or if you prefer Telegram, I'm a bit more active on Telegram. So you can message me directly there. Yeah, that's everything I have in the slides. I don't know, Aubrey, do we have some time for questions here?
If there are any questions or anyone wants to pop in right now and ask live, there is. Otherwise, I definitely think like the Discord would be a fantastic place, or any of these QR codes that you guys see on the screen now. I've kind of been monitoring. I do see maybe one question from Shiva. And hey, John, how's it going? Do you have a question as well?
Hey,
I
John.
threw it in the chat. So excellent presentation, Owen. So I wrote a whole bunch there. So go through Shiva's first, and if you get a chance, I'd love to hear more. So
I think we can answer your questions here first. Do you have a link for the decentralized solver bounty? Yeah, all the links are in the Discord. Just check like the near section. Can you build this as a subfolder in an existing Forge project, or it should be? Was this related to the
yeah,
Discover?
yeah, I'm doing some other work with Fusion Plus right now. So I've got a Forge project for those contracts. So
Yeah, so it should be separate. It's not really related to Forge, I don't believe. Um, I would either suggest forking the example contracts or starting a new repo with the Shade Agent CLI, which you'll see in the docs as well. So those are the two paths I would go down. Can you talk about global contracts? Yeah, sure. Global contracts are really cool. I wouldn't really say they're fitting in this scenario though. Global contracts is basically when you want to deploy many contracts that are the same. So if you want to deploy like a load of fungible token contracts, a load of NFT contracts, or like a load of smart wallets that are very similar, they have the exact same structure, but like different state, then that's when global contracts are being used. But I wouldn't recommend them for anything. I don't think anything in this hackathon should be using global contracts because you're just going to be deploying like one instance of a contract, and each contract you're deploying is going to be like individual. But if you can find some way to use global contracts that are beneficial, then sure, that'd be awesome. Front end repo for interacting with Fusion Plus.
you actually just gave that in your example, like you gave an example of that. So the NPX create whatever.
Yeah, use that. I guess it depends what you mean by Fusion Plus. Do you mean like once you've implemented the near contracts for Fusion Plus or something else?
Yeah, so basically, if we're looking putting a front end in here, it's sort of to do a swap or something. It's like, yeah, something for that.
Yeah, if it's interacting with like a near contract, definitely that NPX create latest app or just one in like the near examples GitHub organization. Um, I guess this is a question for you, Aubrey. Is this recording on YouTube, I guess?
Yep, I think I had posted the link, but some of the AI note taker comments pushed it down. But I just reposted that link there. The full workshop will be live.
And reaching out to me, my Discord ID, I have no clue what my ID is. I'm Owen in the Discord. You'll see me in the like near section of the Discord. I'm the big orange muscly cat. My profile picture is pretty unique there. So you should be able to find me. And if I'm not responding, feel free to ping me on Telegram. I seem to respond to that a bit more.
Sounds good, man. Thanks, buddy.
No worries, thanks. Then I see another question here. I guess we can do this one and then finish up here. If we use Shade Agent for decentralized solver for Fusion Plus, will we still need something, some off-chain, something off-chain for coordination? So yeah, the Shade Agent itself is off-chain. And ideally, you should put as much as you can in the Shade Agent. There are elements to this which are off chain and outside of the Shade Agent, outside of the trusted execution environment. And that is like handling the deployment of more solvers. So you might need some off chain or outside of TE stuff. I'll leave that up to you as you're building it. But anything that should be verifiable, just whack it in your Shade Agent. It's literally just like a normal server, but running in an execution environment, and you build like a Docker image for it. Yeah, I hope that answers your question. Yeah, happy to take more async.
Nice. And I think just the final question about does this hackathon have a limit of 3 bounties? It does. I think that that's going to be kind of the standard for all hackathons moving forward. So just make sure you guys are choosing wisely, of course. And like I said, the last link there in chat is this full workshop live. Always great to see you, Owen. A lot of fantastic information. We really appreciate you being in the Discord and kind of just around if anyone else has questions. So thank you so much and hope you guys have a wonderful rest of your day.
Thanks a lot. See you guys.